Okay, this is Mrs. Wilkoskis. This is the first video I'm making for your review. If you've ever watched any of my videos from the library, I'm not very particular. I might be yelling at my kids in the background. So if you're looking for me to win any awards here, you're not going to get that. So just bear with me. If I talk too slow or too fast for you, down in the cog on the settings on YouTube, you can actually adjust the speed of the video. So keep that in mind. When we spoke this morning, and I'm really excited about teaching you guys. It's been a while since I've been in the classroom. But we talked about you guys struggling with the vocabulary. So I thought I would go over these key terms, and we'll talk about amphoteric substances in just a few minutes. And I will post in a couple more videos. I have not seen Miss Bartolome's review. I'm tracking that down, and once I do that, I will post any types of equations or some example calculations that you might need. But at this point, I'm just going to go over these key terms. I'm going to go up to, I think, ion product constant, because once we get into ion product constant, we go into the calculation. So I'll make that into a different video. And I try and break down the videos so they're not too long, but I'm not always successful at that. Okay, so one of the things, you know the chapters on acids and bases, and you need to know the characteristics of acids and bases. Acids taste sour. Most foods are acidic at some level, or they could be neutral. Things like milk, dairy products, think of Sour Patch Kids, anything that lemons, things that make you like, I don't know, kind of wince when you eat it. Those are acidic foods. Okay, so think of acids taste sour. Bases taste bitter. We do not eat as many bitter foods as we do eat acidic foods. The bases that I can think of are like wine, things that taste bitter when they're not quite right. Coffee can be bitter, tea can be bitter because they're slightly basic. Okay, so think of bitter and basic. Okay, because you're going to have to know the difference between some of the characteristics. So think bitter, basic, which makes sour the other one, which is sour. I mean, acids the other one, which is sour. Okay, the other one is their bases are slippery. Soaps and cleaners are slippery. So if you feel soap and if you put it between your fingers and it feels slippery, that's because it's basic. Most cleaners are basic. And when you watch the video that I assigned on something about ammonia, it talks about why ammonia and other bases make good cleaners. Okay, so that's just some of your basic characteristics. That's how, however many years ago they came up with acids and bases. That's how they told the difference between them, because they didn't know anything about all of this kind of stuff here, the Arrhenius acids and bases. Okay, so Arrhenius, I don't remember what year that was. That's supposed to be an A. I don't know if you can read my handwriting. Okay, they initially thought of acids and bases as something that it was an H plus donor, and an Arrhenius base is an OH minus donor. So when we think of Arrhenius acids, we think of things like HCl, H2SO4, HBr, something that has H at the beginning and a negative ion at the end. These are the ones that you've probably learned how to name when you were naming compounds a couple chapters ago. Arrhenius bases are the ones that have OH, a hydroxide ion in the formula. Something like NaOH, CaOH2, LiOH, goes on and on and on. So those you've seen before, but the actual definition of an acid and base is a little bit more broad than that. So these are Arrhenius acids, and those are the ones we can pretty much easily identify. Then there's a Bronsted-Lowry acid and a Bronsted-Lowry base. And we'll talk more about that when I do a video on conjugate acids and conjugate bases, but there is a difference. And I feel certain you're going to have to know that for the test. Like I said, I have not gotten all the paperwork to take over the class, and I haven't seen everything that's expected of you, but that's pretty standard. So this is the first initial, most narrow, most general definition of an acid, and then they've expanded it. Okay, a Bronsted-Lowry acid is still an H plus donor. Okay, but a Bronsted-Lowry base is an H plus acceptor. Okay, and you've seen those when you do the conjugate acid base pairs. So, like I said, different video. I'll do that later on tonight. Okay, pHs of acids are always less than 7. 7 is neutral. Below 7 is acidic, above 7 is basic, and you probably remember this already, but your pH goes up to 14. It doesn't go past 14, or we don't deal with that. Then the other thing is litmus paper, which is an indicator paper. I think you must have done I did know that you were held accountable for this, so I just wanted to talk to you about that. It's an indicator paper. It tells you whether something's acidic or basic. It doesn't tell you how acidic or how basic, typically. Depends on but litmus paper certainly doesn't. Litmus paper turns red under acids and blue under bases. So I always thought that was hard to memorize. So again, I use that alliteration. Bases taste bitter. Bases turn litmus blue. So if I can remember that bases turn litmus blue, then I know acids is the other one. So kind of keep that in mind. Okay, so those are your physical properties of and the characteristics of acids and bases. Alrighty. The next term was hydronium ion, I think. It's a little bit further down. A hydronium ion is a water molecule with a proton added, or a hydrogen ion. In case you don't know why this is called a proton and not a hydrogen ion, it's the same thing. Remember, a hydrogen atom has one proton and one electron, right? So an H plus ion has lost an electron. So what does it leave? One proton. So oftentimes we will refer to an H plus ion as a proton. So water reacts with the H plus that's given up by an acid and turns into a hydronium ion. And we'll talk more about that when we talk about ion product constant. But that's one of those vocabulary words, and I wanted to make sure we talked about our vocabulary words. So that's where a hydronium ion comes from. Okay, strong acids, and I should have said, I think the other vocabulary word is weak acid. But what I'm about to explain to you holds true for strong bases and weak bases. So a strong acid, the book uses this basic formula. A is just talking about any negative ion. So it could be, or any acidic. This is going to be an acid where this is the hydrogen that's acidic. Okay. So we're going to say, I'm trying to think, I think they gave some examples of your strong acids. I don't think you have to memorize those. They are in here. Let me see if I can find them for you. I know I saw them. Acid strength. I don't see them. Hold on. I'll find them. I think they gave you a list somewhere. Let me find them. There we go. Oh, no, it just talks about common strong acids are sulfuric acid, hydrochloric acid, nitric acid, and perchloric acid. I'm at the bottom of 389. I don't remember thinking that you had to memorize those. If that's true, I'll let you know. But you have to know what a strong acid is. And a strong acid dissociates completely. What dissociates means is that these break up. So instead of using HA, because I don't know that that's what the book uses, but I don't know that that means anything to you because there's no atom that's A. So we'll call it HCl because that HCl is a strong acid. And what that means is when it dissolves in water, when it is aqueous, it breaks up into its ions completely or near completely. Okay? In a weak acid, something like acetic acid, let me see if there's anything easier. That's weak acid. The weak. I'm on page 387, and I'm looking at weak acids. I was going to look for a weak acid. They gave you some examples. An example would be vinegar. Would be a weak acid. CH3, CHCOOH. Okay, and we'll talk about this more in a minute. Okay, that's a weak acid. It's an oxyacid. If you've seen that vocabulary word, and we'll talk about what that means in a second. I'm about to run out of time. I'll pick up here in the next video.